Hello students, today we are going to discuss another important class of coordination compound which is called as metal carbonyls. Metal carbonyls are the coordination compound in which the ligand is actually carbon monoxide. Carbon monoxide is the ligand. So that ligand with the metal is called as metal carbonyls. So in this video we are going to discuss about some important metal carbonyls and the bonding in the metal carbonyls that we are going to discuss in this video. So this class of coordination compound that is known as metal carbonyls, it is also called as homoleptic carbonyls because it consists of only single type of ligand, that is carbonyls, that is CO. Carbon monoxide is the only one type of ligand which is present in these. So when you take this example, that is NiCO4, here nickel is the central metal and the ligands here, that is 4 ligands which is present here. All these ligands are carbonyls, that is carbon monoxide. Now we called it as a carbonyls. So here in such compounds, it contain only carbonyl as ligand. You can see only carbonyl is present as a ligand. So such type of complexes we can call it as homoleptic carbonyls. That means the metal carbonyls in which the carbon monoxide only act as a ligand, that is compound which have only carbonyl as ligand. So such type of compounds are called as homoleptic carbonyls. So let us take some examples of homoleptic carbonyls. The first example, that is tetracarbonyl nickel 0, that is given here. It is tetra carbonyl because 4 CO group are there. Tetracarbonyl nickel, and the oxidation state of nickel here it is 0 because carbonyl group is having neutral ligand. That means it have a charge on the CO is 0 and nickel, and what is the overall charge? It is 0. So if you keep this as X, so what will be X here? The X is equal to 0. That means the oxidation state for nickel here it is 0. That is here the nickel is present as nickel atom, not the nickel ion. So here the oxidation state of nickel is 0. So what is the name for this? That is tetracarbonyl nickel 0. In the Roman in brackets you have to write 0, and it's having a tetrahedral geometry as it is shown here in this figure. The next example for this complexes, that is pentacarbonyl ion 0. Here also the central metal atom have a 0 oxidation state. That is the name of this complex is pentacarbonyl ion 0, which having trigonal bipyramidal geometry. That is how we represented trigonal bipyramidal geometry. These 3 carbonyl and Fe is in the same plane, and one of the carbonyl is above the plane, the other one is below the plane, so that it have a trigonal bipyramidal geometry. So here also the central metal ion have a 0 oxidation state. That means it is central metal atom. Now let us discuss the next example, that is hexacarbonyl chromium 0. Hexa because 6 carbonyl groups are there. Chromium is the central metal atom, and here also chromium have a 0 oxidation state. That is the name of this compound is hexacarbonyl chromium 0, and it have an octahedral geometry. Octahedral geometry, that means 4 carbonyl group and chromium is in the same plane, that having a these 4 CO are occupying a corners of the square, and one carbonyl is below the plane, other carbonyl is above the plane. So this geometry is a octahedral geometry. But there are some or type of examples that we need to discuss. The example is decacarbonyl manganese 0. Here the 2 MnCO5 unit, that is 2 MnCO5 unit, that individually it have a square pyramidal geometry that get unite, that get bind by Mn bond. So this is called as now, that is deca. Why it is deca? Because total 10 numbers of CO groups are there. Therefore deca carbonyl dimanganese, because 2 manganese are there, dimanganese 0 is the oxidation state of manganese here. So that is represented here, and the structure of this, actually the 2 square pyramidal structures that get unite by Mn bond, that makes its geometry in this way. So what will be the name for this one? Once again, here 10 numbers of CO are there, therefore decacarbonyl, and 2 manganese are there, therefore dimanganese, and the oxidation state here is 0. So here the oxidation state for the central metal atom is getting 0 as for the other cases also. One more example that we need to discuss according to our syllabus, because there are number of examples of metal carbonyl, but only we are discussing the examples which is there in our textbook. So the next example is octacarbonyl dicobalt 0. Look at the formula here. Here 8 numbers of carbonyl groups are there. Therefore octa word we are using, octacarbonyl dicobalt, because 2 CO are there. That is, here the difference is there. This CO is actually cobalt, but this CO that is written in the bracket, that is carbon monoxide, that is carbonyl. So don't get confused here. The cobalt can be represented in this way, where the O is small letter, but carbonyl means there both the carbon and the oxygen are in the capitals, because this is nothing but the carbon monoxide, now which we call it as carbonyls. But this CO is actually cobalt, that is symbol CO is the symbol for cobalt. So when you are writing the symbol for a element, the second alphabet should be written in the small letters. So be careful, don't get confused with both the CO which is here in this complex. So that is the name for this is, that is octacarbonyl dicobalt, and the oxidation state for the cobalt here it is 0. Therefore the name for this complex is octacarbonyl dicobalt 0. Now when you talk about when we look at here, the geometry for this one is actually, here there is a bridging between the 2 cobalt, here there is a bridging between these, that means 2, it has CO bond bridge by the CO group. So here a bridging is there in this structure. So that are the some examples of important homoleptic carbonyls. Now we will be discussing the bonding in these. Bonding in the metal carbonyl is in somewhat in a different way it is taking place, that we are going to discuss here. So the bonding in the metal carbonyl is described in 2 steps here. First step, that is, there is a donation of a lone pair that is present on the carbon of the carbonyl group. That electron pair, that is lone pair, which is represented here in red color arrows, there is a donation of this lone pair from the orbital, that is from the orbital of carbon into the suitable empty orbital of metal atom. Once again, this step I will explain once again. As the carbon having the lone pair of a CO group, this lone pair is donated to the empty orbital of the metal atom. So it results in the formation of which type of bonding? That is sigma bonding. So there is a formation of MC sigma bond. But here there is a pi overlapping also involving here. So that is how, because the electron which is present in the metal, that is the electron which is present in the d orbitals, that is the filled d orbitals, that is involved in the donation to the antibonding molecular orbital of carbon monoxide, that is empty. So this is actually the empty antibonding molecular orbital of carbon monoxide. So here there is a donation of a electron from the metal to the ligand, and also the donation of electron from the ligand to the metal. So here this type of bonding is called as back bonding, or we can call it as back donation. So this is actually results in the pi bonding. So here there is a speciality that here the ligands are also involving in donation the electron, that is from the ligand to the metal, and also the metal is involved in the donation of electron, that is from its filled d orbital to the empty antibonding, that is represented as pi star, from filled d orbital of metal to the empty or the vacant antibonding molecular orbital of carbon monoxide. So this result in the formation of pi bonding, that is shown here. Pi bonding is shown. So here there is a sigma bond formation, and also there is a formation of a pi bond. So the sigma bond formation is taking place when the ligand is contributing the electron for the bonding, that is donation of electron, that is a lone pair of carbon monoxide to the central metal atom, and the pi bonding is results, that is due to the donation of electron from the filled d orbital of metal to the empty antibonding, that is the pi star molecular orbital of carbon monoxide. So this type of bonding where there is a back donation, like one is giving, the other is giving back. So we can say this type of bonding is called as back donation or back bonding. That is called as back bonding, because here the ligand is giving the electron for bonding, and that is given back by the metal. So that is called as back donation or back bonding. So here, because of this type of bonding, the metal and the ligand bonding create a synergic effect, which strengthen the bond between the CO and the metal. So this is called as synergic bonding also, because there is a synergic effect between the metal and carbon monoxide. So this type of bonding is also called as synergic bonding. So this is the most speciality of a type of bonding which is found in the metal carbonyls. So this is all about this video. Have a nice day.